In this video, I am going to explain how to find the extreme values for the given function. Okay, so what is meant by extreme values? Extreme values means a maximum and a minimum values for the given function. So first, in the first line of the solution, what you are doing is you are writing the given function. Given f of x comma y is equal to, just copy it down from the question. And then you are finding the solution for this question by two parts. Okay, in the first part, what you will do is you will do the necessary condition to find the maxima or minima. In the second part, you do the sufficient condition to find the maxima or minima. Okay, so in the necessary condition part, what you are doing is you are finding dou f by dou x. Dou f by dou x is denoted by fx, and then again partially differentiating with respect to x. So we get fxx is equal to 6x, and then you find fxy. It means what? Fxy means what? Dou f by dou x into dou f by dou y, right? So just write dou f by dou x as it is, and in the place of dou f by dou y, substitute the value of dou f by dou y. Okay, already we have found. Okay, I will show you. So in the place of dou f by dou y, substitute the value 3y square minus 12. Now what is mean by this? We have to differentiate this with respect to x, but here is no x term, right? Here is no x term, so you get 0. That is how we got fxy equal to 0. Okay, so look at this. We got fxy is equal to 0, right? Similarly, you do for y, partially differentiating with respect to y. Okay, so dou f by dou y is equal to, you get this, and this can be written as fy. Am I right? Now you are partially differentiating this with respect to y again. So you put fyy is equal to, when you differentiate this with respect to y, you get this. Okay, so after that, put dou f by, this is the necessary condition to find the maxima or minima. Okay, so these are the ingredients. You can say these are the ingredients to proceed the problem further. Okay, so this is the necessary condition, actual necessary condition to find the maxima or minima. So here consider dou f by dou x equal to 0. It means put dou f by dou x equal to 0. So from this you find the value of x, and similarly you put dou f by dou y equal to 0. From this you find the value of y. Okay, using these two, write the critical points. Okay, using these two, you write some of the 4 points, and these points are called critical points. Okay, so keep that aside, and after that you are finding the value of you are finding the necessary condition to find the maxima or minima. Okay, so the necessary condition to find maxima or minima is, here you have some conditions, you have to know that. The necessary condition to find maxima or minima, first one is, if this value fxs fyy minus f square xy greater than 0. Okay, if you get this value greater than 0 and fxx greater than 0 and fyy greater than 0, then you say that point. Okay, you substitute the value, that point in the, when you look at the problem, you can understand what point they are talking about. So here, if all are greater than 0, you say that point as a minimum point. If this value is greater than 0 and this 2 is less than 0, then you say that point is a maximum point. And if this is less than 0 and this is less than and this is greater than, less than and greater than, right? So if this kind of point is called a saddle point, and look at this, this is less than 0, this is greater than, this is less than. So also this kind of point is called saddle point. So these 2 points are called, if you get a solution like this, then okay, you say that these points are saddle points. So let's see how to find the minimum point, maximum point. Okay, so these things you should know. Okay, then only you can in the problem, if you get the values like this, you could put that in point is a minimum or maximum, whatever it may be. Yeah, here look at this, what I told. you have to find fx's fyy minus f square xy value and fxx value and fyy value, right? That is what they are doing. Find value of fxx. Here you have fxx, right? Fxx, in the place of fxx is equal to 6x. In the place of x, you substitute the value. Here listen, first you have to consider this point. Using this point at 1, 2. Using this point, you are finding fxx. In the place of fxx, in the place of x, you substitute the value of this x. This is x, this is y, right? So just substitute the values. Find fxx, fyy and fxx, fyy minus f square xy values. Okay, here look at this. Fxx, fyy minus f square xy value is found in this manner. Right, fxx value, fxx is 6x into fyy is 6y and f square x fxy value is 0, right? So that is why here is 0. So the value of this is 36xy. So here using that you have find with this point you have find all these values. Here you have a look at this. Fxx is greater than 0, fyy is greater than 0 and this is also greater than 0. So what I told, if everything is greater than 0, okay, if everything is greater than 0, it is called minimum point, right? So this point is called, this point is what? This point is a minimum point. Similarly do for this point and this point. So at this point you get this is a maximum point and for this point, for this point you are going to get this is less than, this is greater than and this is less than, right? This kind of if you get this kind of values, then what is mean by that point? That point is a saddle point, right? Similarly for this point you are also get the saddle point. So finally, for what point you got maximum value? This point, right? So just write here maximum value occurs at -1 comma -2. Therefore this substitute this -1 comma -2 in the given function. Okay, f of -1 comma -2 is what? The given function. In the given function, in the place of x substitute -1, in the place of y substitute -2. So you get 38 and also minimum value occurs at this, right? So in the given function, substitute in the place of x substitute 1, in the place of y substitute 2, you are going to get 2. Therefore the extreme values are, what are the extreme values for the given question? 38 and 2. So I hope you understood. Thank you.